Hi, this is John Fallows, V6EY in Calgary, Alberta, Canada. And today we're going to do a video about canceling RF interference. So a few years ago, I did a video called Adventures with RFI, or Radio Frequency Interference. Now that video described my efforts to track down sources of interference both in my home and in my neighborhood. And showed you various techniques and tools you can use to find sources of noise. Now, quite often when you find a source of noise, you should first try to get rid of it, but sometimes maybe you don't have cooperative neighbors, or you don't know your neighbors, or there's just so much interference that you can't really get rid of it. So how do you deal with that? How do you reduce the amount of noise? Well, the tool for that is called a noise canceller, and in this video we're going to talk about using noise cancelers. Now, before we get started, here's an outline of what's going to be in this video. First of all, what is interference? How does it work? How do noise cancelers work? What's the theory behind them? And do they really work? Well, the best way to demonstrate that is with some examples of canceling noise or interference. And then lastly, we'll talk about how to build a noise antenna system that does a good job of picking up the noise so you have something to work with. So those are the four topics that we'll cover today. Before we start, we need to differentiate between noise and interference. We mix those words up quite often. So let's go back to basics. Really, noise cancelers are poorly named. They should be called interference cancelers, but we're stuck with noise cancelers, so we'll stay with that. When you start out, the purpose of a radio receiver is to discern a signal in a sea of noise, right? And so in order to understand how radio receivers work in the face of noise and interference, you need to know what noise is. And basically, noise is everywhere. So we all live with noise. This graph shows various types of noise on various ham radio frequencies. Over on the left is an S meter that shows S1 for weak signal, S5 for medium, and S9 for strong signals. And we look across these three frequency bands. First of all, on 4 megahertz, which is a lower part of the HF, most of the noise that you're going to face there every day is atmospheric noise. Atmospheric noise is like, static crashes, thunderstorms, that sort of thing. And typically on 4 megahertz, which is the 80 meter band, you might have atmospheric noise ranging from a low of S1 to a high of S9 with an average around S5. So it's there all the time. On 14 megahertz, you get a little bit less atmospheric noise. So on the 20 meter band, generally you'll always get an S1 or S3 reading on your S meter, with a typical atmospheric noise being around S2. When you get up to 21 megahertz, which is towards the higher end of the HF bands, you really don't have much atmospheric noise, but you get galactic noise from the stars, from the solar system. And that's typically maybe S1 to S2. So that's atmospheric noise. It's always with us. We can't get away from it. Different times of year, there might be more, like during the summer with all the thunderstorms, there's a lot more. During the winter, it tends to be a bit quieter, at least on the lower frequencies. On the other hand, the orange bars here show the typical levels of man-made noise. At the higher frequencies in shortwave, man-made noise is what causes most of the problems with good radio reception. It really limits what we can do. So you can see that on the lower band, sometimes if you have a lower atmospheric noise, you still might get walloped by some man-made noise. And on my favorite band for long-distance communication, the 20 meter band, it's really man-made noise that I have to deal with mostly, and which is why I'm making this video, to talk about how we can reduce it and get a lot more enjoyment out of our radio hobby. So what are the sources of man-made noise or RF interference? Well, the number one source really is switch mode power supplies, or switching power supplies. Those are those little wall warts that you have to charge your phone, or to plug in to power your monitor, whatever. And your computer has a switching power supply. Quite a lot of the home appliances you have, like your washer, will have a switching power supply. and so on. So they're the number one source. Then they can be quite complex in the types of noise they create. Computer and network gear especially can give off noise from the power supply, but also the oscillators running in the computer and network gear can be a prime source of birdies. Home appliances, very popular source of noise. My front-loading washing machine, which we'll show you the noise from later. Plasma televisions, your neighbor might have a plasma TV that can put out a lot of noise. And DSL leakage or DSL IP television coming to your home can have signals leaking out because DSL uses the high frequencies for sending digital television to your home. So those are some of the more popular sources that you have to deal with. So let's talk about regulatory failure. You would think all of these devices, especially the power supplies, would be regulated to limit the amount of noise that they give out. Well, and they are. They really are. So, for example, for your switch mode power supply powering your computer or your phone or whatever, it has a conducted limit of 50 dB microvolts, or 50 dB above 1 microvolt. That's a decibel is a measurement of ratio. So, for example, if you take a compliant power supply, which actually meets the regulation, it can give off 50 dB microvolts. Now, at 50 meters distance, that's radiated interference is going to decrease because of something called path loss. But it'll still be around 25 to 30 dB microvolts signal coming into your antenna to your receiver. So just in case you haven't figured it out yet, even a properly regulated, compliant switch mode power supply can put off enough noise back into the power lines to distribute around your neighbors and result in an S7 or S8 level of interference. So you're really on your own when it comes to dealing with these kind of challenges. And this sort of shows the various relationships between signals and noise measurement, that a strong radio signal that would be an S9 is really just barely above the legal limit that could be coming from your neighbor 25 to 50 meters away. So forget about getting any help from regulators. You've got to deal with these problems yourself. So there's four main types of interference that we all have to deal with, and I'm just going to go quickly through each one. And the two types shown on the top of this graph are what I call statistical noises, because you can use statistics to get rid of them. The easiest example is the tone up in the top left, or a birdie, a single frequency tone that might be coming from your computer or network gear. And you've got a tool built into your receiver called a notch filter. It's usually an automatic notch filter. So because all of the parts of this signal are highly correlated, it's a very precise correlation of signal. It's a single frequency. It's very easy to notch that out, and a notch filter can knock it down by 40 to 80 dB. It can just get rid of it. So there's one thing you can do. If you've got a simple tone, you can just get rid of it when it gets into your receiver. At the other end of the statistical spectrum is uncorrelated noise, or white noise. Now, atmospheric noise is primarily what they call white noise or Gaussian noise. It follows kind of a normal distribution. And because of the statistics, it's also quite easy to reduce the effect of white noise. Your noise reduction feature in your receiver can knock it down by 10 to 15 dB quite easily. So those are the easy ones. The harder types of noise to deal with, in the bottom left, we've got impulse noise. Now, a typical impulse noise is a spark plug in a motor, or it could be something like sparking. Power line noise is impulse noise. When you get sparking across insulators on a power line at 120 cycles per second, that'll give off impulses. Impulse noise is something you want to keep out of your receiver. So what we have there is something called a noise blanker, and noise blankers were invented, I think, around 1935, and what they do is they just turn the receiver off very quickly once an impulse comes along, like for a few microseconds, and then turn it back on again. And that works. Down in the bottom right is complex interference, and really this is what we get that we have to use an external device like a noise canceller to deal with. It's just too complicated. Once it gets into your receiver, it's a mixture of tones and broadband noise and impulses and all kinds of stuff. It's really a jamming signal. And this is where noise cancelers come in. So how do noise cancelers work? Well, basically, you want to pick up the noise signal and reverse its phase 180 degrees. Because if you take two signals and one is a reversed copy of the other and you add them together, they cancel each other out, and it really works nicely. And that's exactly what these noise cancelers like the MFJ 1026 or the Timewave ANC-4, that's what they do. You plug your antenna in and then plug your radio in and also a separate noise antenna. And you pick up the noise signal, you reverse it, and then you try to get rid of it. And this basically is how it works. On both of these devices, you have a separate noise antenna that you optimize to pick up only noise and not much desired signal. And then you either amplify or attenuate it, shift its phase 180 degrees, and then add it together. And you end up reducing the effect of the noise. You get mostly the signal that you want. And these things really do work if you have a good noise antenna, which is what we'll focus on later on. And the controls are really simple. You have a gain and a phase control, and the trick is to try to get the noise that you're receiving on your noise antenna to match up with the noise you receive on your main antenna, but you reverse its phase, and ideally it will cancel out. So what I'm going to do now is give you some examples, and I've got 6 examples. So the first one is no noise, clean bands. This is what it's like at my home listening on my shortwave gear when there's no interference from the neighbors.
Básicamente voy a hacer referencia a algunas de las primeras representaciones gráficas del Che hechas por creadores de las artes plásticas de Cuba.
So there's an example of clean bands, and if every day was like that, if I just had a little bit of atmospheric noise and no interference from any home appliances or power supplies, I wouldn't need a noise canceller and life would be wonderful, but it's not. So now we're going to give an example of one of my worst noises, and that is the low voltage halogen transformer, these sort of electronic transformers. And this is from the lighting system in a house that's about 150 meters away from me, and it wipes out some of the bands, and I've gotten quite good at just getting rid of it using the noise canceller. Here we go.
Asuntos Sociales y Ministro de Educación de la República Democrática Timor-Leste, Antonio de Conceizao, llegó a Cuba para complementar una visita oficial que se extenderá hasta el próximo día 15 de junio. La delegación timorense dialogará con autoridades de nuestro país, ocasión en la cual se fortalecerán más los vínculos de amistad, solidaridad y cooperación existentes entre ambas naciones.
Expertos de Cuba participan en el Foro Internacional de Seguimiento a la Cumbre Mundial de la Sociedad de la Información, que se tiene en la ciudad suiza de Ginebra hasta este viernes por convocatoria.
Con la instalación del primer cable de esquí en zona hotelera Jardines del Rey, ubicado en la central provincia cubana de Ciego de Ávila, como parte del aspirar creciente de la industria de los juegos. Directivos del MINTUR explicaron que la nueva atracción recreativa abrirá sus puertas a finales de año en Cayo Guillermo.
So you can see in that video that the ANC-4 does a great job of reducing noise from that transformer about 150 meters away. You probably noticed you get two kinds of cancellation. You can tune or peak the cancellation for a specific frequency, but you can also get a cancellation across an entire band of frequencies. And this is something that the ANC-4 and the MSJ can do quite well if they're set up. Now, you can also use these to get rid of birdies. Birdies are very annoying. There are single tones that come along and can drive you crazy. And if you like, you can use your notch filter, but you can also use the ANC-4 or the MFJ to remove tones. And you'll see a whole bunch of tones that disappear whenever the ANC-4 gets turned on. There, they're coming back, and now we'll push the button again, and they'll go away.
I got the noise level correct. They go 0 Austin, guys. Okay, Helen. George 0, Echo Austin Alpha Mobile from Echo Alpha 5 India Kilo Juliet. Good afternoon, Helen. Thanks for the call. My name's Paul, P-A-U-L. I'm located near the city of Valencia. You're 5 and 9 here, Helen, and I'm beaming towards North America at the moment. It's a nice signal. G0EA, sorry, EOA, EA5IJJ.
So there's an example of using a noise canceller to get rid of birdies. You can use the notch filter, and in fact the Flex radio's got a tracking notch filter that'll get rid of them at the front end. So there's various ways to deal with those. Okay, the next one we're going to look at is washing machines. So I have a Whirlpool Duet front loader, and it does all kinds of wonderful square wave manipulation to get extra torque out of the motor when it's washing. And you can always tell these devices they have got a very distinctive pattern of coming on and off for a few seconds, and you can use your ANC-4 to reduce them or make them disappear almost entirely. So there's how to use a noise canceller to reduce the interference from your front-loading washer. I've actually put a toroid on the power cord of mine and managed to knock that down quite a bit. This is from the washing machine a couple of houses over. Okay, some of the noise we have to deal with is very complex. It's a mixture of plasma TV and power supplies, and it's all over the place. And so this next video shows you a mixture of different noises that I'm canceling from my neighbors. I often switch back and forth between different antennas to find the noise antenna that works the best, and usually I can get some good results.
I'm not a pilot, not licensed. I'm a pilot guy. I never really tried to get my system on that. But it was fun.
Is that loader tractor still there if it is not usable for anything? And why can't it be sold in a smaller skid steer that would clean out the barn and be purchased? Or why don't you
sometime. So K5, YV launch for your final. This is K Quest 12. Get out of here once you're done, my friend.
I've never thought about that little square in the diving board, but you should leave your home a little bit more often. I'm talking about the dog, not Shirley over here. Okay. I don't know whether Charlie, you're just done or got a lot of junk. I haven't figured it out yet. Yeah, well, what Mom does with me, she just brings a mirror in and puts it over my mouth to see if I'm still alive in the morning. Yeah, I've done this for 55 years. Got by with it, but the older she gets, the crappier she gets. Tomorrow we'll get one of them iron skillets. You know it? Yeah, you might. Well, August 2nd this year will be 59 years for us, so kind of same deal, Charlie. Yeah, we kind of try to tread lightly sometimes, but that doesn't apply to me. I've actually been working 10 and 6 meters lately. It's amazing. Go ahead, Woody. Yeah, we had a little 10.
So if anyone ever tries to convince you that these noise cancelers don't work, I hope these videos have convinced you that they do work. You'll notice a lot of the signals that I was clearing up so that I could hear were quite weak down around the S2 to S3 level. I was able to reduce the noise enough to get good copy. So I've saved the most dramatic example of how well these things work till last. Here's a short clip of some 15 megahertz shortwave broadcast with some very nasty interference, and it's pretty well cleared up on the frequencies that I'm listening to by the ANC-4.
You certainly have to let the topic to go first. You can't just raise that and investigate a profitable process. So these are the kinds of competing situations at the moment. But the one event is what we get a point in mind. And also it's the fact that the Chinese investment in the domestic market is now rising. Interest rates are going up. So on the rate also
होली हो तुम क्या जानो अब भी मुझको पहचानो सपना तुम्हारा मैं हो मानो या ना मानो होली हो तुम क्या जानो अब भी मुझको पहचानो सपना तुम्हारा मैं हो मानो या ना मानो देखो ना जानी से मुझे ये तो तेरा नहीं तो जाती ही रहो
So there you go. There's my examples of how well these noise cancelers work on a variety of different noises and a variety of different frequencies. The trick to getting good performance is to build a good noise antenna system. In my case, I built two vertical antennas, voltage probe antennas, and I'll show you how I made them in just a minute. They're basically a piece of plastic tubing with a wire running in it, and I have them positioned at the edges of my property as close as I can get them to the neighbors that have the most noise that I have to deal with. I use 4-foot vertical dipole or ground plane. It's a 1/2-inch PVC conduit with embedded number 14 wire. I clamp it to a fence or something to place it vertically. I find most RFI is vertical polarization. I 3D printed some end caps to hold the wire in place, and I 3D printed a connector to connect RG6 coax to some screw terminals for the antenna. And here's a picture of the 3D printed antenna connectors. I love building things with my 3D printer and putting them together. And here they are. I've got 3 of them actually mounted in 3 locations, and each one is switched when it comes into my shack. So I can select which noise antenna for which neighboring house, and it works just great. So, in summary, noise cancelers do a great job of reducing RFI from noisy neighbors. Their success depends on good noise antennas and their placement. If you want more information, check my website, Making It Up, at play.fallows.ca. And I'd love to hear from you about any of your experiences, and print a few articles if you like about how you have used these devices to make radio listening enjoyable again, which is really what it's about. You can't get rid of the noise unless you have some sort of noise canceller to at least reduce it down to a tolerable level. Thanks a lot. All the best from Calgary.